So hi everyone. So in last video we have to already discussed two colligative properties RLVP and elevation in boiling point. And in this video we have to continue remaining two colligative properties. One is depression in freezing point and the last one is that is called osmotic pressure. Okay. So what is freezing point? Initially we have to discuss the freezing point of a solution is temperature at which the solid form of a liquid begins started separated from its liquid. Okay, that means from a liquid the solid must be separated from its liquid. Okay, at a particular freezing point, it is called freezing point. Okay, so what do you mean by freezing point of a solution? So the solution at which its vapor pressure also decreases. Okay, so we know that when a liquid is added to a non-volatile solute, then its vapor pressure decreases. Okay, and the lowering in vapor pressure of solution is causes to lowering in the freezing point. Okay, at lower temperature, so that the solution has decreased its freezing point, right? So let's discuss with the help of a plot. Suppose we have to draw a plot vapor pressure versus temperature, right? In Kelvin, this is vapor pressure, this is temperature, right? And you know the freezing point. Okay, so we have to discuss solution and solid, that means at a pure solvent. Okay, so the lowering in vapor pressure of a solution is when, that means the vapor pressure of freezing point also decreases. Okay, so in other way we can say that the a solution is freezes. Okay, a particular solution will freezes when, so the vapor pressure of solution is equal to the vapor pressure of its solid pure solvent as compared to the pure solvent, right, at low temperature. So that why the vapor pressure of or freezing point of solution decreases. So okay, what we will see in the graph. Okay, so this point is called what? Frozen solvent. This is the frozen solvent, right? And this point is what? Solvent. Okay, and this is solution, right? Now suppose in the particular solution the freezing point of solution, you take TF. Okay, TF is what? The freezing point of solution. TF naught will be, you take freezing point of solvent. Okay, now the difference in freezing point, what happened? Which is highest curve? The solvent. This is the TF naught, freezing point of the solvent. This side is for solution, TF freezing point of the solution, and the difference in represented by what? Delta TF. Delta means change or difference, right? So in difference, what they represent? Delta TF is equal to TF naught minus TF. Why TF naught? Suppose we think that why solvent minus solute, sorry, solution, because from this graph you just check TF means freezing point of the solvent, right? TF naught. So that way TF naught minus TF. Okay, and we know that the freezing point, or so in this case what is delta F? Here delta TF is what? depression in freezing point, depression in freezing point. Clear? So the depression in freezing point, we know, which directly proportional to the molar elevation constant. Okay. So डेल्टा टी एफ क्या हो जाएगा हमारे यहाँ पर, डेल्टा टी एफ मोलर एलिवेशन कांस्टेंट, व्हाट इज एम, एम इज व्हाट, sorry, हाँ molar elevation constant after removing proportionality, right? So delta tf is what, depression in freezing point, which is directly proportional to what, molality. Molality is what, we know that molality is what, number of moles of a solute dissolved in mass of solvent in kg. This is the molality. That means how many number of moles of solute present in 1 kg of solvent, right? In other way we can express, okay, and in this expression just remove proportionality symbol. Delta tf is equal to what come out, 1 proportionality constant. So kf in this case is called what, molar elevation or constant or cryoscopic constant, right? Now we know molality is what, we know molality is represent small m symbol. Molality is what, weight of a solute. Okay, I will take W2. Okay, so in molality formula we put in kg, mass of solvent in kg. Suppose we express in gram, so what will happen, divided by 1000, so 1000 will come to the numerator. So for that what you will do, W2 is the weight of the solute multiplied by 1000 whole divided by M2 into W1, okay, into kf is also there, right? Sorry, direct नहीं करेंगे. Suppose this is equation 1, this is equation 1, right? Now put the value of m in equation 1. What we will get? Now equation 1 becomes, what happen, delta tf is equal to m into kf. So this value of m will fit in equation 1, W2 into 1000 upon M2 into W1 kf, where W2 is the weight of the solute, M2 is molecular weight of the solute, W1 is mass of the solvent in gram, right? Okay, and kf is what, cryoscopic constant or molar depression constant, right? ठीक. Now so we need, suppose we need calculate molar mass, okay, molecular weight of the solute, okay, implies M2 is what, weight of solute into 1000 into kf, okay, whole divided by what, delta tf come to that side, so delta tf into W1. So from this expression we can conclude that for calculating molecular weight of the solute we need the values of what, delta tf, depression in freezing point, weight of the solute, weight of the solvent into kf. What is the value of kf? The value of kf is what, 1.86 Kelvin kg per mole. Okay, so this must be remembered. Okay, and sometimes the value of kf is given in the question, otherwise you can remember, right? Done. Now let's do some numerical questions. The freezing point of solution, write down question. Freezing point of a solution is prepared by 1.25 gram non-electrolyte and 20 gram water is 271.9 K. Calculate molecular weight of solute. Use Kf is equal to 1.86. Okay, now solution. So what is given? So freezing point of solution is prepared by 1.25 gram non-electrolytes and 20 gram water is, that means freezing point of a solution given what? 271.9, right? And 1.25 is what? Double, that means weight of what? Solute. And 20 gram, that means water and non-electrolytes combined together to form a solution whose freezing point is what? 271.9. Okay, so this is the solvent. Right? So given TF solution is what? 271.9 K. Okay, and what is freezing point of the solvent? Water. What we know, water freezes at 0 degree Celsius. So 0 degree Celsius means what in Kelvin? 273 Kelvin, right? So TF naught, that means freezing point of this solvent, 0 degree Celsius or 273 Kelvin. Here we put in Kelvin only because solution of freezing point also given in Kelvin, right? Again, weight of solute given 1.25 gram and weight of solvent 20 gram. Okay, by applying formula M2 is what? Okay, so again, so we can calculate delta TF. Delta TF is what? TF naught minus TF is equal to what? What is the TF naught? 273 Kelvin. 273 Kelvin minus 271.9. 273 minus 271 to 1.9, 1.1. So 1.1 Kelvin we get delta TF. Okay. Again, Kf value also given. Now putting. Okay. Therefore, is equal to into 1000 upon delta TF into W1 into Kf. So it is coming out what? 1.25 into 1000 into 1.86 whole divided by delta T coming out 1.1 into 20. So it is coming out calculate कीजिएगा. Okay, so it is coming out after calculating 105.6 105.28 the solution, right? ठीक है. So come to next properties, colligated properties. What is that? Osmotic pressure. Okay, osmosis, osmotic pressure, and we will also discuss reverse osmosis. Okay. Take. So last one is which fourth? Osmotic pressure denoted by pi. Okay, so before that we have to discuss what is osmosis. Okay, so what is osmotic pressure? So before that we will learn that what is osmosis. Osmosis means what? See, the net flow of or inflow of the solvent into solution through a semi permeable membrane is called osmosis. Okay, and in daily life we have to come across different kinds of situations. Sometimes when any person faced into accident and admitted into hospital, doctor will, okay, given the saline. Okay, so why the doctor giving the saline to any patients after an incident? Okay, so for that, during bleeding of the bloods, okay, because the osmotic pressure falls down, so that way to maintain the osmotic pressure the saline is must. Okay, so this and well, to for the reverse osmosis we have used reverse osmosis for desalination of seawater to getting fresh water. Okay, so let's start. So osmotic pressure means what? Osmosis you get already. So what is osmotic pressure? Okay, so osmotic pressure means when external pressure is must applied, okay, in order to stop the flow of solvent into solution through a semi permeable membrane. Okay, so whenever we talk about semi permeable membrane, okay, so what is it? So membrane are different kinds. Okay, in membrane parchment paper, okay, cellophane paper, these are also acts as a membrane, right? So what is the semi permeable membrane? So semi permeable membrane nothing but the membrane which allows to allows the molecules only of the solvent to pass through it, but not the molecules of the solute, and the solvent and solution separated by a specific membrane is called semi permeable membrane. Okay, so let's understood by a neat in diagram. Suppose so in this container I want to put a tube also. Okay, so in this pressure is there and H is the height, right? So this is the solution and this point is so this is solvent and this in this solutions are there, and this point is the semi permeable membrane. Semi permeable membrane, right? In shortcut we can write down SPM, semi permeable membrane, right? Okay, now so this is the solvent and this is solution, right? So the membrane which separate the solvent and the solution through a specific membrane is called semi permeable membrane. Okay, but the solvent is always flows into the solution only, right? Or this is called what? Hydrostatic pressure. Osmotic pressure is also called or hydrostatic pressure, okay, which developed into the solution to proceed solvent into the solution with the help of the pipe. P is the pressure, right? So hydrostatic pressure is also equal to what? Osmotic pressure, right? So pi is the osmotic pressure, okay, pi is represented for osmotic pressure, is equal to HdG. So how osmotic pressure is equal to H is what? Height in the level in the level of this tube, okay, in the particular solution. And what is D? D is what? Density of the solution, density of solution. G is what? Acceleration due to gravity, acceleration due to gravity, all of you know. Small g is acceleration due to gravity, okay. H is height in the level in the tube of the solution. Take. Now we have to compare this experiment with Van 't Hoff factor, okay. And Van 't Hoff factor is also called what? For applicable abnormal colligative properties, right? So let's see. Now you can note down this all things, okay. I am erasing because here is a small board, okay. So okay, say Van 't Hoff dilution law. So what is this? According to this law, the gas equation, which is the ideal gas equation, PV equal to nRT, okay. This Van 't Hoff dilution law states that in a gas equation PV equal to nRT is also followed by osmotic pressure law or dilution law, okay, that in which pressure is replaced by pi, osmotic pressure. This pressure replaced by osmotic pressure. So what happen? Pi, if P is replaced by pi, so we have to put pi in this place of P. Pi V equal what? N into RT. What is R? Universal gas constant, whose value is what? R is equal to 0.0821, okay. And T is absolute temperature, implies pi is equal to what? N upon V RT is equal to C into RT. C is concentration, okay, number of moles per volume, okay, is equal to what? Concentration. So pi is equal to what? Cr into T. So at constant temperature, what happen? Pi is directly proportional to C. So that means concentration is more, means osmotic pressure is more, okay, simultaneously. Clear? Now so it's proof that osmotic pressure is a colligative properties and depends upon the osmotic pressures, okay. On the basis of osmotic pressure, solutions also different kinds. What are these? Isotonic, hypotonic, hypertonic. So how? Let's understand. Suppose for isotonic solution means what? That means the solution in which both have the same osmotic pressure. The solution have same osmotic pressure is called isotonic solution. For in primary condition, suppose pi 1 is equal to pi 2, both the solution has osmotic pressure is the same, so that equal, okay. Or C1 is, yes, C1 RT is equal to C2 RT, right? So at temperature, so at secondary condition, secondary condition, what happened? C1 is equal to C2. So that means N1 upon V1 is equal to N2 upon V2. So hence we proved here isotonic solution follows these conditions, right? Now one is a hypertonic and hypotonic. In case secondary, this is one, okay, hypertonic or okay. So hypertonic whenever pi 1 greater than pi 2, that means in between two solution, one solution has a greater osmotic pressure as compared to other solutions, okay. Otherwise concentration of one solution greater than concentration of other solution, okay, or C1 greater than C2, okay. So according to this condition, solution 1 isotonic is also called what? Hypotonic, and this is follow also what? Condition 2 is called hypertonic solution, okay. So hope is it clear to all of you? Now do some numericals, okay. So in all my videos I have discussed the all the entrance questions, especially NEET, JEE Mains and JEE Advanced, okay. So don't skip the questions, practice, okay. So do some question, okay. A question is given, what is osmotic pressure of 12% solution of a cane sugar molecular weight given 342 at 17 degree Celsius. Answer. So what is the formula of cane sugar? C12H22O11, okay, and mass of what? 342. So given mass also, okay. Now so we know pi equal to what? CRT or N upon VRT. We need pi only, okay. So 12% solution of a cane sugar, okay. So means what? 12% of cane sugar solution means what? 12 gram of cane sugar present in 100 gram of solution, right? 100 gram of solution, ठीक. As 12 gram present in 100 gram implies 1 gram, what happen? 100 upon 12. But for 342, what will be for 342? Implies for 342 present in what? 100 divided by 12 into 342, okay. Again to convert into, we need volume, so convert into volume, what we will do? Divide by 1000. Double zero cancel out, so 12, 3 4 is 12, 3 1 3 1 3 4, okay. 4 is 8 83, point, this again 2 means carry 0, so 0 4 5 is 20, okay. So it is coming out 28.5 upon 10, that means 2.85 liter. The volume we get 2.85 liter. Now so pi is equal what? N upon V into RT, okay. So number of moles is what? 1. Why? Because 342 my divided by 342 number of moles, the given mass upon molecular weight, so 1, number of moles 1. So what happened? VRT, okay, V into RT, clear. So what is V? 2.85 into what is your 0.0821 into 290 to 90. Okay, calculate. Okay, so in this case, sorry, so number of moles is 1, so 1 upon V into RT. So this means what? Implies pi is equal to RT upon V. So what is R? 0.0821 into temperature is given 17 degree Celsius, so we convert into Kelvin. So for Kelvin, degree Celsius plus 273 equal to 7310 carries 290. Okay, so 290 upon what is the volume? 2.85. So after calculating, we will get what? Calculate. So we get, after calculating, 8.358. Right, this is the final answer. So hope you getting all the concept what we discuss in this video. Stay tuned, we will discuss all the entrance levels here. Okay, so God bless you, have a nice study.